Hey everyone, I'm Pranshekwa and welcome back to my YouTube channel. Today we will be solving today's Leetcode daily challenge, which is find missing observations. So let's see what is this question and how we can solve it. So in this question, you have observations of n plus m six-sided dice rolls, okay, with each face numbered from 1 to 6. N of the observations went missing, okay, and you only have the observations of m rows. Fortunately, you have also calculated the average of n plus m rows, okay. You are given an integer array rows of length m, where rows I is the value of the ith observation. You are also given two integers mean and n, okay, and n is the number of observations which went missing. And we need to return an array of length n containing the missing observations such that the average value of n plus m rows is exactly mean. Okay. If there are multiple valid answers, then you can return any of them. But if there is no such array exist, then you should return an empty array. And what do we mean by an average? An average value of a set of k numbers is the sum of numbers divided by k, right? And note that the mean is an integer, so the sum of n plus m rows should be divisible by n plus m, right? So let's see. So in this first test case, we have been given with this m observations, right? These are m observations, and n observations of the row of the dice went missing, right? And this is the mean of n plus m observations, right? So let's say if we have n units, so and its mean is x, right? So what we can write is, if we have n numbers, let's say n1 plus n2 plus n3 till n, right? If we have n numbers and their mean is x, what does it mean? It means n1 plus n2 plus n3 till n divided by n is equals to x, right? This is mean. And if the mean of n numbers is x, then we can say this, right? So similarly, we can apply that mean formula here. So if the mean of n plus m numbers is this, so we write it something like 3 plus 2 plus 4 plus 3 plus n numbers. It means 2 numbers. So let's say n1 plus n2 divided by n plus m, which is m is 4 and n is 2 and the mean is 4, right? So what it will become? 3, 3, 6, 10, 12 plus n1 plus n2 is equals to, it will go here, 4 into 6, 24, right? So n1 plus n2 will become 12, right? So we came to know that the sum of missing observations is 12. Okay. So for a minute, can we just suppose these two observations equal? Okay, let's suppose if these are equal, then what it will become? 12 and n1 will become 6. Okay. So like, as we came to know that the sum of n observations is 12. So we have considered that might be all the observations are equal. If yes, then we came to a number 6. And 6 is also less than or equals to 6 and greater than or equals to 1, right? It means it is the number which can exist on a dice. So the observation which we have made, that the two missing observations are equal, can be true, because can both these observations can be 6. Yeah, so our answer will become 6 here. But what if this number is not completely divisible by this number? Let's see how we can solve that case. So in this case, what our answer will become? 6 comma 6, right? This will become our answer. Let's see the another test case to understand better. So in this test case, what we can do is 1 plus 5 plus 6 plus 4 observations. So let's consider all the observations are equal, right? And n plus m, 3 plus 4, 7 equals to mean. Okay, so 6, 6, 12 plus 4n1 is equals to 21. Okay, 4n1 is equals to 9. Now see here, if we divide 9 by 4, then we get 8. Then we get 2, right? With a remainder of 1. Okay. So the observation which we have made that all the 4 numbers are equal. And by the end what we get? 2 plus 2 plus 2. But no, it is not true, because we are getting 1 as remainder. So if 1 is remainder, so can we just increment one number by 1? Yeah, now its sum becomes equal to 4, and the mean of rows and this will become equals to 3. So if in the case of remainder, we will just increment that numbers by 1. Okay, so let's see another case. So in this case, 1 plus 2 plus 3 plus 4 plus, let's again consider all the numbers to be equal. N plus m is 4 plus 4, 8 is equals to 6. Okay, 4, 3, 7, 3, 10, right? Yes, plus 4n1 is equals to 48. Okay, 4n1 is equals to 38. Now n1 is equals to 9, which is not completely as well, and with a remainder of 2. Now if we have considered that all the numbers are equal, but by the end we are getting 9, which is greater than 6, right? And 9 cannot exist on a dice. So in this question we will be returning an empty array. So see, what we have done here is that if we got a number greater than 6, then we simply return an empty array, because that number cannot exist on a dice. Okay. Now if there is some case and we get n1 as 6 but remainder as 2 or 1, then also we will be returning an empty array. Why? Because 6 can exist on a dice, but there is a remainder also. It means we have to increment one observation by one number. So we cannot, if we increment 6 by 1, then it will become 7, and 7 cannot exist on a dice, right? So what condition here becomes is that if n1 is greater than 6, then we will definitely return an empty array. But one more condition is that if n1 is 6 and we have some remainder also, then we will be returning an empty array, because 7 cannot exist on a dice. Okay, let's understand one more case. See here, 6 plus 3 plus 4 plus 3 plus 5 plus 3 divided by plus 6 and 1 divided by 6 plus 6, 12 is equals to 1. So here it will become 10, 15, 18, 21, 24 plus 6 and 1 is equals to 12. Now 6 and 1 is equals to minus 12. See here also, we are getting n1 as minus 2, which also cannot exist on a dice. So one more condition which we have is this: if n1 is less than 0, then we will be returning an empty array. If n1 is greater than 6, then we will return empty array. And if n1 is equals to 6, but remainder is not equals to 0, then we will be returning an empty array, right? So these are the conditions in which our answer cannot exist, and if these conditions doesn't fulfill, then we will simply go with our observation of n, and we simply increment the remainder digits by one number, right? So let's see how we can code this. So first of all, we will store its size, rows dot size, and first of all we will make the sum of m observations. Okay, so for int I is equals to 0, I is less than m, I plus plus m, sum plus is equals to rows of I, right? Okay, now after this what we need to do is, first of all we need to calculate our num. What is num here? Okay, let me tell you. So num is mean multiplied by m plus n minus of m sum, right? Num is our this number, this a mean multiplied by m plus n minus m sum, right? So we have calculated this. Now we need to divide it by n to find whether this observation, to get our observation, and to find whether this is greater than equals to 6 or not, to apply those conditions. So what our observation will become? Num by n, right? And what our remainder will become? Num modulo n. Now we will apply those conditions. If our observation is less than or equals to 0, because 0 also cannot exist on a dice, or our observation is greater than 6, or our observation is equals to 6 but our remainder is not equals to 0, then we will simply return empty array. Otherwise, in the starting also we will declare our result vector, right? Now if we have some remainder, so what we need to do? We need to increment the remainder digits by 1. So we will simply increment the remainder digits by 1 and push that in our result vector. Observation by plus 1, and we will push the remaining digits as it is. Remaining digits, how many remaining digits will be there? We have n digits in our n observations total, and we have already pushed remainder observations, so remaining observation will be n minus remainder, right? So result dot pushback observation, and by the end we will simply return our result. Now let's try run this. Yeah, it's working fine. Let's try submitting it. Yeah, it's working fine. So now let's talk about its time and space complexity. So as you can see, we have used this one loop for doing the sum, and these loops which are running total of n times. So its time complexity will become big O of n plus m, and if we consider the space of this result vector, then its size will be n, so its space complexity will become big O of n, right? So this is all for this question. If you still have any doubts, then you can post in the comment section. I will surely try to answer them. Bye guys, see you in the next video. Till then, keep learning and stay curious.